Today we're going to do our soil lab, investigating properties of soil. The materials needed are your lab sheet that you have in front of you, sand, silt, which is the topsoil, loam, a potting soil, gravel, which we're using a smaller gravel, what's called pea gravel, coffee filters, water, and graduated cylinders, which is this tool up here in the top left. Your lab sheet has different sections. The first section A is the investigation conclusion, so we'll do that after we complete section B. Section B is the observations, which we're going to do here in just a moment. Section C is the lab design, which will be the third step that you will complete. Section D will be your independent work, which is your final question that will be completed after the entire front side of the sheet is filled in and we've done the entire lab investigation. So if you look at section B, the observations, you have instructions at the top of that section. It's called write a descriptive word in each box and then rank each property 1 to 4. Color will be ranked lightest being 1 all the way to 4 being the darkest. Texture will be ranked from smoothest to roughest, so 1 being the smoothest, roughest being 4. Particle size will be 1 for smallest, all the way up to 4 as the largest. And the retained water amount will be 1 for the least amount to 4 for the most amount. We're going to start with our color. You can see the 4 different pictures. Sand in the top left corner, the gravel in the top right corner, the loam in the bottom right corner, and the silt in the bottom left corner. So you can see the differences. They're all in the brown family, but we got to be a little bit more distinctive than that. So we're going to go ahead and give them a little bit of color variation when we name them, and then we'll rank them from lightest to darkest. So I went with tan for the descriptive word for sand, light brown for the gravel because it is a little bit darker, medium brown for the silt, and then dark brown for the loam. And so they're already actually in order on your chart. So 1 for tan, 2 for light brown, 3 for medium brown, and 4 for dark brown. So go ahead and make sure that you have that written on the color section of your chart, the descriptive words and the number rankings in those boxes. Next is texture, and I have some short little videos that we're going to watch. I can't make them any bigger, so I'm going to play them a couple of times each, and you can see how the different soil samples go through my fingers. And we're going to describe how we think they feel and then rank those. So the first one on the top left is the sand. Okay, I'm going to play it one more time. And then on the top right, we have the loam. One more time. The bottom right, we have the pea gravel. And one more. And the last one on the bottom left is the silt. And you notice that some of them do flow through my fingers a little easier than others. So after feeling them, we're going to rank the texture of how we think they feel. So the texture for the sand was gritty. Felt kind of like sharp pieces. And then the gravel was rough because it's the rock material. The silt was kind of silky, soft feeling. And then the loam was very light and fluffy, almost like cotton. So when I ranked those, remember we were ranking them from smoothest to roughest. Fluffy would obviously be 1 for smoothest, and then the silky feeling would be number 2 for the silt. 3 would be the gritty for the sand, and then rough would be the hardest texture, so that would be 4 for the gravel. So go ahead and make sure you have those written in your texture box of your chart, and we're going to move on to the next section, which is the particle size. So here we have the particle size. In the middle, I have a bigger picture of the 4 soil samples with a little sample next to each word: the sand, the gravel, the silt, and the loam. And then on the sides, I have a little closer up picture of each one so we can see what they look like. We're trying to test particle size. So that means a single grain of the particle, not a handful, just like a single piece that you could put on your finger. So we're ranking those from smallest to largest. So we can obviously tell which one's the largest. That would be the gravel pieces. The other 3 are a little harder to tell, but you can see a grain of sand, kind of like you can see a grain of sugar or salt on your finger. They're all 3 roughly the same size. So that would be our next largest. And then the loam would be a little smaller, but you could still see a single grain on your finger. And then the smallest of these choices would be the silt, because it's more of a finer powder, so it's a lot harder to see a single grain of it. So if you look in the chart, I have sand as large, gravel as extra, extra, extra large, silt as small, and loam as medium. Now these are just in comparison to each other because they're all fairly small particles. So then we just rank them: 1 for small, 2 for medium, 3 for large, and 4 for the triple large. So go ahead and make sure you write that in the particle size section of your chart. And we're going to move on to the last section that we're testing, which is the retained water amount. Okay, there's a video that we're going to watch, and I'm going to kind of explain as the video is going how the test worked for retaining water. Okay, here we have 2 graduated cylinders. So we have one is going to be trial 1 on that chart that you just saw, and the other graduated cylinder will be trial 2. So we're testing both trials at the same time. And we're pouring water through each soil sample that's sitting on a cup on top of the graduated cylinders. And we're starting right here with the sand samples. And we pour the 100 milliliters of water into each one. And we see how much of that 100 milliliters goes through the soil sample into the graduated cylinder below. So then we could subtract that number that was on the graduated cylinder from 100. So you can see here, once we did the subtraction, graduated cylinder 1 had 40 milliliters of water that stayed in the soil sample, and graduated cylinder 2 had 34 milliliters of water that stayed in the soil sample. So that's what I mean by retained water. If it stays, it's retained. Okay, the second sample is the gravel. You can see that in the cup. And it's in a coffee filter, just like the sand was. And we pour the 100 milliliters of water into each one. The water flows through, filters through, and then we're going to do our subtracting again. Whatever measurement we get on these cylinders, we're going to subtract those both from 100. And I know it's kind of hard to see the numbers. If you look at the one on the right, it had a 60 and then an 80. Yeah, here we go. It had a 60 and then an 80, and the water level is a lot closer to the 80. So then when we subtract that from 100, we get our answers. Okay, so for the gravel, we had 20 milliliters in the first graduated cylinder and 18 in the second. That's how much water was retained in the gravel. Okay, so we're going to move on to the silt sample. Doing the same test, pouring the water onto the silt, and it filters through the silt and the coffee filter and through the hole in the bottom of the cup, and starts to fill up the graduated cylinders. Now you will see the phone in the background. We were using a timer because we didn't want to wait forever, so we were timing it. Every example was timed at the same time. So we measured the silt doing the same process, and we were using the timer on every sample that we did. So for the silt, there was 32 milliliters of water that was retained in the first graduated cylinder and 38 milliliters in the second graduated cylinder. So the last sample we're testing is the loam. And you can see we have the loam here in the cups. We're going to pour the 100 milliliters of water into each one. Let it filter through the loam and the filter, through the bottom of the cup and into the graduated cylinders. And we will measure the amount of water again and subtract both of these from 100. So you can see our final chart has the 30 milliliters for trial 1 and the 34 milliliters for trial 2. So we end up taking the average of all of those. So when you average them, that means you add the two trials together and then you divide by 2. So when I did that, we end up with these numbers. Our average milliliters for sand was 37. For gravel, it was 19. For silt, it was 35. And for loam, it was 32. So then I just ranked these from the lowest number to the highest number. So go ahead and make sure you have this information written down in the retained amount water section of your chart. The next section is section A, the investigating conclusions. So we're going to pause the video here so that this will be on the big screen and we can do this part as a class, and the teacher will read through each one and we'll discuss these answers and you will fill them in on your paper. The lab design section, we're drawing a bar graph. So you can see at the bottom, we need to write down the sand, gravel, silt, and loam as our 4 soil types. And then we're taking the measurements from the retained water amount and we're drawing a bar up to each of those amounts. So you can see for the sand and then the gravel, the silt, and then the loam, where the numbers match up with the numbers here on the side amount of milliliters absorbed. And make sure that each one of your bars is a different color. The last section is section D, and you're going to do that question on your own so you can read that on your paper. And you will complete the question, circle the correct choice, make sure that you're using your strategies to work through the problem. And then when you're finished, you will turn in your lab sheet, and this is the end of our soil lab. See you next time.